Hello, this is Anup Saw from Kolkata. Today I will discuss about the projectile motion under gravity, and we will find out the highest point expression as well as the time of ascent and time of descent and total time of flight and also the range. Okay, now see here on the screen you are seeing a picture in which an object is fired from point A, and it is describing a circular path, not circular actually, the path will be called parabolic path actually, and it reaches to a maximum point P, and thereafter it goes down, and at the point B it strikes the ground. So if it is projected with velocity v at an angle theta with the horizontal, this velocity v, here you are seeing this picture v can be resolved into two perpendicular components. One component along the x-axis is v cos theta, okay, and the other component is along the y-axis is v sin theta. Now v cos theta tries to push the object towards the right direction, that is the movement, the horizontal movement is due to the v cos theta component, okay, and v sin theta tries to push up the body in upward direction, okay. Now first we will try to find out the time of ascent, that is the time taken by the object to reach from A to point P, okay. Now we know very well that at this point P there is no velocity component in upward direction, otherwise the object would move further, but this is the highest point, so definitely this component v sin theta must be 0 at this point. So if the time taken is t1, so let us use this formula, v is equal to u minus gt. Here v is the final velocity, u is the initial velocity, and t is the time taken. Now in our example final velocity is 0, okay, and the initial velocity towards the upward direction is v sin theta minus g is the acceleration due to gravity, and t is the time taken, that is t1. So here on rearranging we'll find that gt1 is equal to v sin theta, that is t1 is equal to v sin theta divided by g, okay. Now we will again find out an expression for the time taken by the particle, that is the object to reach from point P, that is highest point, to the point B, that is the point of striking, okay. So we will find out the time of descent in the similar way. Here I am making a small separation, time of descent, okay. In the similar way, here at this point B the velocity component v sin theta, okay, will have a direction in downward direction, okay, it has a downward direction, and as energy will be conserved, okay, we are supposing that there is no friction force or negligible friction force, so the energy will be conserved, so the object will reach to the ground at the point B with the same velocity, so it will have a downward velocity v sin theta component, but in downward direction. Here it was in upward direction, but here it will be in downward direction, okay. Again we will use the formula v is equal to u plus gt. Here you are finding that for descent purpose, that is for downward fall, for fall, for downward motion, we are using the plus sign over here, and for the upward motion we are using minus sign here. You should remember this thing, okay? Because g has a value minus g value, g has a negative value in upward motion and g has a positive value in downward motion, okay? So here this v is the final velocity. You know very well that this v must be equal to v sin theta is equal to u, initial velocity is 0, plus g, and here again the time taken, let us suppose that this is time taken t2, and on just rearranging we will find that t2 is equal to v sin theta divided by g. The same result we are getting here. Time of ascent is v sin theta divided by g, and time of descent is v sin theta divided by g. So two results are same, so we are concluding that time of ascent must be equal to time of descent, and this must be, otherwise the energy conservation law will not be valid. So the total time of flight will be total time of flight, that will be equal to t1 plus t2, and this will be equal to v sin theta divided by g plus v sin theta divided by g, and will be equal to 2v sin theta divided by g. Next we will discuss about the horizontal range. What is horizontal range? Actually, the total horizontal displacement of the object, okay, I am making recurring mistake, whatever. The total horizontal displacement of the object during the motion, throughout the motion, is the smallest distance between A and B, that is AB, and this AB is here range, okay? So we are to find out the range, that is the total horizontal displacement of the particle when it is projected at an angle theta, okay? So range is also a distance, okay, whatever displacement, and this must be equal to velocity into time taken. Now velocity in this direction, that is towards the right direction, the velocity is v cos theta, so you are using here v cos theta, and the time taken will be equal to the total time of flight. In the previous earlier we came to a conclusion that the total time of flight was 2v sin theta divided by g. So 2v square sin theta cos theta divided by g will be the expression. On rearranging we will get v square 2 sin theta cos theta divided by g, and 2 sin theta cos theta, this whole thing is equal to sin 2 theta, so it will become v square sin 2 theta divided by g, okay? Now if you replace the theta by 90 degree minus theta, what we will get, okay? Let us see. We know very well this is the expression of range, okay? You know very well that sin 2 theta is equal to 2 sin theta cos theta, but if we replace the theta by 90 degree minus theta, that is its complementary angle, what we will get? We will get 2 sin 90 degree minus theta cos 90 degree minus theta. This is equal to 2 cos theta, and this will become sin theta. So again we are getting the same result, that is sin 2 theta will have no effect when the theta is replaced by 90 degree minus theta, so it will have no effect. So when the velocity is constant, okay, if the same velocity is applied, with the same velocity is projected, and if the body is projected with the same velocity at two different angles, but they will be complementary to each other, then the range will be same. Okay, then the range will be same. And this is the thing we must know. Sometimes in MCQ type of questions it is asked that there is one angle 30 degree and the body is projected at 30 degree angle. For the same range, at what angle the body should be projected? So it will be 90 degree minus 30 degree, that is 60 degree. Okay. Now we will try to find out an expression for the maximum height attained. Okay, so in the here we are finding here that the vertical projection from the point P, the vertical, if a line is projected on the if a line is projected on the line AB from the point P, this vertical distance is the height attained, and P is the highest point over here. We have to find out this vertical displacement, the maximum vertical displacement occurred. Okay, so let us try to do it. Okay, in the upward motion, okay, in the upward motion there is a component that is v sin theta, and in the horizontal motion there is a velocity component v cos theta. Okay, so we know very well that time of ascent is t1 is equal to v sin theta divided by g. This is the time taken. Okay, and again we know from the motion formula that v square is equal to u square minus 2gh, where h is the height attained. What is v? V is the final velocity and u is the initial velocity. So initial velocity is, we know very well, in upward motion there is a component v sin theta. So then v sin theta square minus 2gh. Okay, h is we have to find out the value of h. Now final velocity at the highest point, there is no velocity component at the highest point P. There is no velocity component in upward motion. So in the expression, the final velocity will be equal to 0. So on rearranging, we will find that 2gh is equal to v square sin square theta, and this will give h is equal to v square sin square theta divided by 2. This is the maximum height attained expression. Okay, thank you for watching the video, and if you like this video, then do subscribe